This video is going to talk through the difference between rational and irrational numbers. So the letter Q is represents rational numbers because the letter R represents real numbers, which is all of the numbers that we know of. And then irrational is represented by I because of irrational. So there's a couple differences between rational and irrational numbers. Please take note of these differences. So first thing about rational numbers is any number that can be put into a fraction is rational. So the first thing that we're going to write under rational are fractions. Okay, so you should know what a fraction looks like. Anything that can be literally turned into a fraction is rational. So things that can be turned into fractions that we know of here are whole numbers. Literally positive counting numbers, including 0. Then we have integers, which are positive and negative counting numbers. All right, all of those can be turned into a fraction by putting a 1 under them. Then we have perfect square roots. So for example, the square root of 1, square root of 4, the square root of 9, the square root of 16, square root of 25. Okay, because square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, square root of 25 is 5. All of those turn into whole numbers. And we could go all the way up. We could do 6 times 6, which is 36, 7 times 7, which is 49. And everything that is a perfect square root is rational. All right, then we have decimals, certain decimals. Decimals are rational if there's 2 ways that they can be rational. The first way is if they end, so terminating. So if they do not go on forever and ever and ever and ever, they're going to be able to be put into a fraction, and therefore they are going to be rational. So like 0.123, I can put that into a fraction by saying 123 over 1,000. Okay, so anything that ends, I am able to turn into a fraction. And then lastly, any decimals that repeat themselves. Okay, so like they repeat the same numbers over and over and over again, I also can turn into a fraction. So for example, when we see a repeating decimal, it's going to look like 0.1 with the line over it. That means 0.111111 on and on forever. And any decimal that repeats itself can be made into a fraction by putting it over 9. So this is equal to 1 over 9. Okay. Another example, if I have 0.12 repeating, that represents that I'm doing 0.121212 over and over and over again. And I can turn that into a fraction by making it 12 over 99. Okay, so however many numbers repeat themselves is however many 9s I'm going to put on the bottom of my fraction. So those are all examples of rational numbers, things that can be turned into fractions. Irrational numbers are things that cannot be turned into fractions, right? So the first one, pi. Pi is always irrational because it is a non-terminating decimal. It goes on and on forever. It doesn't have a pattern. There's infinitely many decimals in pi, and people are still finding them. And so that is an irrational number. The next would be non-perfect square roots. So anything between these perfect squares, so like the square root of 2, the square root of 3, the square root of 5, the square root of 6, the square root of 7. Okay, anything that goes between the perfect square roots, any square root that is not a perfect square root is going to be irrational. If you put those in a calculator, you're going to get decimals that go on forever. They don't repeat. They don't have a pattern. They are non-perfect. Okay, and then to go along those lines, decimals that are non-repeating and non-terminating are also irrational. So if they don't repeat, if they don't have a pattern, okay, you can't turn them into a fraction. And if they have to be both these things. If they don't repeat and they don't end, they're just numbers that go on forever, and you can't turn them into a fraction because we can't just say like, okay, if this decimal goes on and on and on forever, we don't have an end point, so we can't turn it into a fraction because there's nothing I can put it up over. And it doesn't have a pattern, and so it can't be, you can't put it over 9s or anything. All right. So those are the two definitions of rational versus irrational.